Hello everyone and welcome back to Root and Route. I'm Diljit and today we are stepping into the third module of REST CLI engineering. In this session we are moving beyond the basic syntax to build a high profile security focused tool, shellcode transformation engine you can call it. We'll be implementing encryption using XOR and AES in a piece of shellcodes, and it will help us to assess your AV antivirus or EDR signature detecting capabilities. So if you are today, I don't have much slides to show and explain other than giving you a formal definition of what is shellcode is. If you are not from cybersecurity background, this is a definition for shellcode, and I'm pretty sure it will be a bit confusing for you if you never worked with shellcode before. But I can say it's a position independent piece of code that will normally it is written in assembly, then translated into direct machine opcodes. And don't worry about those kind of terms. I'm planning another course that will be teaching how to manually develop shellcode from assembly code, so it will be more clear for you at that time. Basically, the nature of the shellcode is it is designed to inject into a running process memory and directly executed by the CPU to perform some dangerous tasks, and most famously spawning interactive shell. So the spawning interactive shell is a feature that blocks by the antivirus or EDR at the time of execution. So today we are trying to develop a tool that will help us to encrypt shellcode in memory, and encrypt shellcode inside the binary and decrypt it in memory, then directly trying to execute by your running process. So now I hope you understand why AVs and EDRs are very strict on detecting signatures, and why I did add AES encryption to this one is because XOR is working and it was working perfectly in the past, but some of the modern EDRs or antivirus heuristic engines, it has capabilities to detect XORing patterns, so it will be difficult if you are really testing AVs or EDRs signature capability. It will detect easily, so that's why I added a feature for AES-GCM. And if you have any doubt on what is XOR and AES-GCM, I did a very detailed course on that on my previous video, the second part of REST CLI engineering. There we did really a deep dive into both, how it works, how the algorithms works, and I think it was a very long video, nearly 1.5 hours, so you can definitely refer that and learn that first before doing anything with this course. But if you are okay with that, if you are the person who doesn't need to be worried much about how the encryption works, you can definitely follow this video and try to do the encryption and decryption shellcodes. So that's about the introduction. Let us dive deeper into our shell coding part, the real project. So I will be I think what I can do is we will be mostly using the same encryption and decryption techniques that we were using on the previous course. So I just want to save time, so I can just copy paste the previous code that we already did, especially those external libraries will be the same here for AES-GCM and random generations and other stuff. And we did I hope you remember that the AES-GCM encryption and decryption, we did make it as a real CLI tool that accepts parameters from the command line. So we'll be using the same techniques here, so it will be easy for us to reuse the code and saves our time. We'll be focusing more on parsing of the shell codes and formatting the shell code for after this encryption and decryption. So let us dive deeper into that. First we create our new project. Let's call shell transformator. I don't know. Shell transformator is a word, something like this, I don't know. Or it will be like, okay, make it like shell code cipher, and let it be like this. New, cd shell code cipher, and open it. And as I said, we don't want to do everything from scratch. Instead, we already did a part of it. So what I can do here, EDRs, CLI engineering. Here we, cd AES-GCM, and trying to open it here. Since we are going to use the same, we need all the same number of dependencies that we use here, because we will be using the same thing. Therefore, this one, on cargo.toml file we are using the same set of dependencies, and I explained everything well in the last video, why we are using all these things, the relevance of these. So the other thing that we can make is from the previous project might be the way that we, I think we need, we didn't, we did, okay, we did, we may need this one. Here we didn't directly use it because we just mentioned directly using the full path here, so we didn't use it on the use section of the project. So, but in a new one we will be using that. Okay, let me copy the other ones. There is here. First we let us copy all these things and use it here. And we may need some more let it be very keen this time. Last time we got a lot of errors on this one, so I'm just ensuring this is already used, so we don't need that one. We need random core OSGen. And how okay, before starting this, we need to design our application. Just think of it like a real piece of software that's going to be used in production. But it may take more time to design it properly, but just within the limited time. So what we can do here is we are going to learn how to define our need here. So basically this application, what it's going to do is it's going to accept options from the user. So for choices we can make use of enumeration. It comes with the mode, exactly this one we need, encrypt and decrypt, and is one of the modes that needs to be accepted from the user. So user has to specify whether they want to encrypt or decrypt the code, shell code, Then the next enumerator we can think of is either the cipher, or I can say algorithm will be more fine for this one. Instead of complicating AES-256 something, we can just say XOR or AES. These two will clarify the option for algorithm. Then we need as a selection, we need a formatter. Like we can generate this will be confusing if you are not from cybersecurity. The shellcode output could be either in 0x format or /x format, depends on the programming language that you are using. If you are using C, you can make use of /x format, and if you are using programming languages like Rust, you may need to use the 0x format. So for that, I'm saying it's format, and the format is one is going to be you can say hex 0x, and the next is hex you can say /x. These two could be the format that we could make use of. Now there are some more specific things that we had to use here using these enumerators. Is called derive macro. So what is going to do is derive. The first one should be debug. This will help us to exactly debug the values, the user specific values. If you want to print the values to the console, you need this one, because if you don't use the debug, you won't be able to print it while if you want to test the values on this enumerators. For that we need debug. Then you must need clone and copy. Like here it comes the ownership rule. If you don't use this one, the copy or clone, what is going to happen is when you're passing these values to some other functions, it may take the ownership of that, so we may not be able to use it after that. So when you're passing it as a copy of the enumerator, it will be like the primitive data type integer and characters, so it makes an exact copy of that. So that copy will be a new variable or new place in stack, so it doesn't matter for you, you can still use it. So it is a must for enumerator, especially if you want to pass the enumerator around functions. So the other one, the famous one is and of course we need to compare the values of enumerators. It's like just imagine if you want to check the mode is encrypt or decrypt, then you have to specifically do an equal to check in if conditions. Then at that time you need the compiler checks whether the enumerator has implemented this partial EQ trait. If you don't implement this and if you try to compare that, the compiler will complain and it will stop building the application. I mean, the compiler will fail you on building the application. So I'm just giving this to every enumerator to ensure that we have the right, we are doing it on the right way. And you see this derive macro on most of the time when you develop applications in Rust, especially when you are going to deal with the enumerator and structures. Now we have the options. Now we define the choices that a user can do. The next thing that we need to do is we have to develop a structure to hold the data. Basically structs, if you have programmed in any other languages, you know what exactly a structure is. A structure holds different types of data into a single unit. So if you have multiple options, you can build a structure and keep everything safe into one place, and you can access it from there. It's kind of container. So what we can do is we can make, oh yeah, config is the best name for that. And yeah, the AE suggesting mode, algorithm, format. Yeah, we need all these things. Apart from that, we need two more things that is not enumerated. In fact, it's the AE suggesting key, input and output, but we need basically a key. Instead of key, we can say is password, because it will be that more readable password, and the path to your encrypted path to the shellcode file. Why we are taking it as a path? Because when on a terminal, if you are trying to paste the shellcode, some of the characters may break, and reading from the terminal, I mean, when you're trying to read the shellcode from the terminal after breaking some characters, will be completely useless when you are trying to do this application. So we have to save it in a file and then try to read it from there to get all the shellcodes, instead of breaking with some because if the terminal is not properly pass any characters inside the shellcode, and from the terminal if you're trying to read it, it may fail. So the next thing we need to do is we are going to learn another important stuff in Rust. It's called implementation block in Rust. You can define methods for structures in Rust using very simple keyword implement. IMPL is a keyword, yeah. Then just mention which structure you want to implement the method. Then here we have to define what exactly you have to. Oh yeah, this is really cool. Instead of, okay, it is suggesting something, but instead of these things, what I can think of is, yeah, I'm taking this, but just say instead of new, I can say it's a build, configuration building. Then take the argument. Don't get confused on this part. Make it like it is going to be a vector of strings. Normally when we are trying to take, we already showed this on the last video. When we are trying to accept command line parameters, it comes as a vector of strings, the arguments. So I'm taking that same here, and of course the if the build function is successful, here to return the config, the same config structure. And don't get confused with the static element here. I will try to cover the static stuff later. Here I'm just saying a string, and here I think this one, there is a function. Oops, I did some mistake on that. Okay, so if is returning a result type, and result type is, again, we explained it on last video. It's another enumerator that will return either OK or error. And if here the OK condition is going to return the same structure, with all the options, and if it's going to be an error, it's going to return a string. So here it is exactly doing the same thing. We just say what is the number of arguments we need. Mode 1, 2, 3, 4, 5. So number of arguments should be, I think, not 5, it should be 6, including the application itself. So if it's going to be less than 6, we can definitely return error, but this error should be formatted because it's going to be a string. And see, that was an error here. See, here we are not returning the exact error object, but instead we are returning a string. So we have to use the format macro that will help us to convert this to a string. Then what we have to say here is the normal stuff usage, what should be, yeah, this will be mode, algorithm, format, password, and path. And argument 0 is always the name of the application. So I think that is enough for this one. Yeah, if the argument is less than 6, it is going to be this. And let mode, yeah, here is the, I mean, why we use the enumerator is it's always easy for us to use the match. So the mode could be not E or D. I think you can make it as ENC and DEC. That will be more readable. And if the first argument is going to be, we are converting the string type to ampersand str type, just to take just to mention that we are not taking the ownership of that. And again here we had to mention format. What to say here is yeah, of course it's going to be unknown mode, it, or you can say invalid mode. That will be more professional. Invalid mode, and we can say it must be or use, yeah, this will be a good message for the user. And algorithm, the same thing. If it's going to be XOR, it's going to be XOR algorithm AES. My god, I have to change the AES additions here also. So this function actually returning either either an OK or an error. So here we are trying to return error from every possible formats. So here you have to use either XOR or AES. Then the format, of course, the format is going to be hex 0x. This is going to be return format in hex, use hex 0x or hex/x. That is very lengthy. We can say /x or 0x. This will be enough for us. So if it's going to be 0x, we are going to get format as x0x, hex 0x. And what happens on this one is when this matching is happening, we are assigning this variable to be one of these values according to the user choice. And of course this is the return value. If everything is going to be fine, we are returning as an OK. Inside the OK, we are saying that it's a config structure with all these values. These are the user choices with enumerators, and then the others are we are directly taking. Why we are cloning here? Because we are not taking the ownership of the strings here. We are just taking the copy of the strings. So these arguments will be free from the ownership issue. So now we have this function, and this is the end of this function. I think, yeah, this is the end of the function, and this is the end of the implement block. So this is going to be the build function that we are going to use when we are going to work with the CLI app. So this is how we are going to use the structure and the implementation. we define the structure with all the data we need, and we define a method for the functions called build, and inside the main function we have to test it, like what is going to happen inside the main function when the user is going to supply the arguments. So we did already in my previous video this part. Let the arguments environment arguments collection, and this is actually I'm explicitly mentioning vector string type here just to avoid the confusion. So now we have a collection of the parameters that's going the user is going to supply, and let config. This is the way we can build the config object. We are calling the build function with the reference to the arguments, and instead of this one, I say I don't need to make it complicated like this. What I can say, maybe because this is going to be this function is returning a result type, so what I can do here is we can match the result. If it's going to be an OK config, then we take the config to this file, this variable, and if it's going to be an error, we just print the error and exit. So will this work? I think it should work. Oh, sorry, we didn't use the match keyword. You have to match it. So now what happens here is, if we build, we are just, why we are using the match here instead of the unwrap or error. The unwrap is always a mess. So it's always, if you know what exactly the result is going to be, just try to match it and do it properly, instead of making the application panic, and sometimes you may not get the proper the stack information from the application. So why it is showing, I think it has some extra sorry, we need to have a semicolon here, because this is inside, not there, it ends here. It should be, it's a statement, actually it's a one statement here, so you have to end the semicolon here for the match, because the match ends here. And so now we need to see, this was some of the things that this is the reason why we implemented the debug on the top of the enumerator. Now it's saying that this config is not implemented the debug, and it's complaining, that's why we can't print it. Normally if you want to print the debugging, if we are implemented this one, we can print the entire config structure using this pattern, but now it is complaining that it's doesn't implement debug. So either you can implement and derive the debug here, it's getting more complicated if you asking the AI, and we don't need, in fact, the clone here. If it's going to be used somewhere, definitely we'll use. Oh, we missed the hash here. So now what we can try is, we can try to run this, just at least build it, just to check our parameter implementation is correct or not. Just cargo build, try to get everything correct. downloading and external stuff, compiling the, yeah, it finished without any error, but it has still warnings. Okay, let us, yeah, definitely the issue we will be facing if is going to complain about regarding the ownership and moving of variables inside the structs, those kind of stuff. But let us see how it is going. Now we have the options and stuff. Now we try to run the application, target and debug. What is the project name? Shellcode cipher. Yeah, the usage, it says shellcode cipher mode and algorithm, format and password. Now for the mode I say ENC, for the algorithm I say XOR, and format, what was the format we had to supply? Yeah, I say 0x. Then after that it is the password. That was, yeah, format, then the password. For password, encrypt, and yeah, we have to specify the file for this one. Just here I'm just say encrypt this.txt testing nc. We are not doing any operations here. Till now we didn't implement any encryption or anything here, but I'm just saying any. So if these parameters are correct, it will print it. Now we just ensure that it has taken the parameters according to the selection that we did. Say the mode was encrypt, algorithm was XOR, and format was hex 0x, and the password was encrypt, and yeah, the path of the file is encrypt this.txt. So now the CLI's options are working. Now the core part of this one, we had to implement the XOR and AES encryption and decryption. So for XORing and AES, actually we already did, so we are not wasting time on that. But for the AES I will show you. But even before that, we have to follow the same structure here. We will be using some more REST features. It's called now we have a structure. It's called what is the data structure, but there is another concept in Rust. It is called what to say, unit struct. Unit struct is nothing but it doesn't make any it's not memory heavy. It doesn't make any big memory allocations. Theoretically it is zero memory allocation structs, so it is very helpful when you have structs that doesn't need to hold any data, but it can have some methods implemented from some other trades. So here it comes a very important concept of Rust. It's called trait. Trait is if you have programmed any other programming languages before, any object-oriented languages before, trait is kind of same concept of interface. It's like it's a common shared set of methods that keeps our software on a specific standard. So you can use when the interface is used, and when we are going to implement the interface, all these methods must be implemented inside the classes or structures according to the programming language. So it's the same concept here. The name is different. It's called trait. So what we had to do is we have to define a trait, so that's going to have the encrypt and decrypt methods. So these encrypt and decrypt method we are going to implement on our structures. Two other unit structures is going to be one for AES, one for XOR. So let us name it as shellcode cipher. Yeah, and we need basically the parameters for this one. Yeah, the first one, let it be like this. The first one is the reference to the trait itself. Trait in the sense, actually, when we are trying to implement trait, REST is going to do a concept called dynamic dispatching. It is nothing but the compiler doesn't know what kind of object is going to be at the time of compiling the application, but at runtime, according to the choice, suppose when the user is going to select XOR, we are going to set the shellcode cipher object as XOR, or if it's going to be an AES, is going to be an AES structure object at the runtime. So that's called dynamic dispatching. The compiler doesn't know what to do at the compile time. So while implementing that, I will show, so it will be clear for you. Now for encrypt function, actually the parameters are something different. If you remember last time we did, we need the actual data, you can say, and it should be a reference to an array of U8. U8 is nothing but a byte array, and either you can say the password is, either the password you can pass it as the same array, or it could be a string reference itself. Just for simplicity, I just made it as string itself here. And after encryption, yeah, definitely it's going to be a vector of U8. That because we are operating the encryption and decryption option on the bytes of the input. So it's the return type will for the encrypt always be a vector, and if you want, you can convert to string. It depends upon the need of this one. Last time we did convert it to string, I think. This time we don't need, because we entirely need an encrypted piece of vector that we have to format. So for decryption, I think the same thing can be done. We will be passing U8 byte array and password. Then the return type we could use is, it's always, I think when we are trying to do the decryption, especially with the AES, it was returning a result. If you have a doubt on that, you just refer the previous video, we were talking about that. So instead of a normal vector, and we are going to do a return type as a result, and the first type, of course, if it's an OK, it's going to be a vector array, and if it's going to be an error, it's going to be a string of that explains what the error is. Now we have the trait. The trait has two methods, encrypt and decrypt. So the next thing we need to define is the two different type of structures that is going to implement this trait. So of course the first one should be first one, it could be XOR, or it could be the AES. It doesn't know first or second, but we need these two structures. So now we have the unit structures here. It doesn't make any memory space or anything, but is going to implement this one. So here we use the same keyword implement, but we are going to implement the shellcode trait for the first one, XOR shellcode cipher. Here it is saying the encrypt and decrypt. Yeah, take this one and just check. Last time, do you remember that we did implement it our own ways? I mean, manually we were going through the first input data, then we were iterating over the data using manual loops, and now the AI is suggesting the rest way of doing stuff. Let us look into that one. It is converting to a vector, then is getting iterated, and is taking, I mean, basically the same logic. It's iterating over every byte of the data, input data, then it is taking the password bytes, I mean password as bytes, converting that to byte, and taking the password length, I mean the index mode, the password length. This is algorithm that we explained on last video, but we did it in manual way. But now they are suggesting in this way. Let us try to do this. If it's not going to work on encryption decryption, we will copy our code from the previous one. So for the decryption, actually there is no need of specific decryption for XOR. You know why? The reason why we don't need it, because XOR is kind of the magical inverse things happen. If you encrypt the same if you do the XOR 2 times, you will get the plain text. Like if first you encrypt that and you get a decrypted data, then if you encrypt it again, you will get the plain text. That's the inversion of XOR. So we don't need this one here. Instead, what we can say, we can call anyway, it should be a result type, so we can call the this method. So if it's going to be, it is going to return a string of vector in normal scenario. So we don't need to implement the decryption for this one. We can just call it using the same data and the password. So we get the result, because the inversion, I mean XOR inversion is same. So now we have the AES implementation. So this one, I think better, I don't know whether we need to take the code from this one or implement it our own way. No, we don't need to take this one, because it's trying to do the static, suggesting the static way of doing it. Implement for what was the name of shellcode cipher, or implement shellcode cipher for AES shellcode cipher. Function encrypt, and let us do function decrypt. See, the AI is blindly suggesting something like this, but it won't work for AES, that we know, so don't worry about that. We are just trying to implement it from our own implementation. Hope you remember that. And if you didn't see the previous video, I will explain the basic stuff we did. We need a salt that is going to be a 0 initialized U8 byte array, and is going to be 16 byte length. And we need another one is called nonce. I can call nonce bytes, and it's going to be a 0 initialized 12 byte length. And then we did fill this byte array with random values using the OS ring RNG methods. Now we have the nonce filled, and next thing we can say, let what we are doing, I forgot that. Just trying to memorize what we did. Yeah, we needed to convert our password to a 32 byte array, because the password that we may supply might not be a 32 byte length. So we will be using this PBK DF2 HMAC and SHA-256 option to convert our password bytes with the salt and making a 32-byte key. So this will help us to get a 32-byte length key based on the password, and based on the password and the salt that we created here. So the salt is random. So now we have 32-byte length password that is needed for AES-GCM. Now what was the other thing we created? Now the salt, nonce bytes, the password, the key bytes from the password. Now we need I think the cipher. Let the cipher be this was the AES. This was the function that we used. I think we did use some other new from slicer. There are so many functions inside that, and I forgot what we cipher equal to. Let it be like this. Is this a result type? I think we did use new some other function from slice or something. New from slice, and inside that we passed the reference to the key. I think I don't know what exactly, but this one. But we just unwrap it and take that result. Let it be like this, but if it's going to crash, definitely it's going to be an issue. So after analyzing the result, we will change it. So now we have the cipher, and now we need, I don't know why all these things just is suggesting too much. Let the cipher text equal to just cipher.encrypt, and while encrypting, what we need, of course we need a nonce from slides. I think we can use this this method, encrypt. It's a reference and data. At least here we don't use the unwrap. We just say if it's fail or not. Encryption failed. Yes, in the AES encryption failed. Otherwise it will be difficult for us to debug it. I think this one needs encrypt needs a nonce, and that is using the nonce bytes here, where we declare the nonce bytes. It is the random nonce bytes. It's not a static one, so it is safe. Now we need to create our own package. Let's say okay, let's say let mute, make it as a result like a package. And what we are going to package is, instead of creating a new vector, we can say it's a mutable package. That is, anyway we have to start with the salt, so here we can convert the salt to a vector, so, and vector is dynamic. We can add more values to the vector, and instead extend from slice, what could be if you use just extend and add the nonce bytes. Is it an error? Let me see. yeah, it's not an error, because we end of it we need these things to when for decryption. I'm not sure we did implement it the same way last time, but yeah, I just tried to memorize the stuff that we did. The basic thing we wanted to do is we have to create a salt nonce bytes and fill it with random values, then create a 32-byte password with HMAC. Then we encrypt our plain data text, the data. Actually, we don't need. The data is coming as a reference, so we don't need it as ref again. It's a reference to a byte array here, so we don't need that. I just say this one, and yeah, basically we have to pack after encryption. We are packing it. Oh, what is the error now? What is this? It says it's not a crate. Or let us remove, because we already used that, I think. And for the SHA-256, okay, the way that we used last time is something different, just like this. And the SHA-256 we were giving the type as in the angle bracket. Don't worry about these things, we already did. I'm trying to recreate it, just trying to remember what it was. SHA-256, then yeah, then it was a password bytes, the salt, and the mute key. Is it okay now? Still it does error. Oh no, it is okay. Basically this is a way of it's a bit complicated, but it is doing something that we need for us. It is converting, don't be so confused here. It is converting our password to 32-byte array, so just to match with the AES-GCM requirement. So I think the encryption is okay. Now we need to decrypt it. For the decrypt, here the statement actually is returning vector. We are not explicitly mentioned the return here. If you are confused on that, you can explicitly mention the package with a semicolon. Both are same. Yeah, but if you want to do it in the Rust way, you have to do it the other way. Now we have to decrypt it. Decryption was the same thing that we have to unpack it. So now we have what we have to do is let salt equal to first 16-byte of data, let nonce equal to the next 12 bytes, and let ciphertext equal to from 28 to the end of it. And we have to do the same thing as we did for the salt here, the same statement. Yeah, the same statement. We have to convert the password to the 32-byte key, and if it's not matching, it's going to complain. And the cipher is the same. And decrypt. Oh yes, the decrypt method we may need to do something different. Yeah, here you can't say expect here because the return type is I'm not sure whether it's correct or not. So the decrypt. Oh, okay. The decrypt is returning a vector error, vector of U8 in a result type, and is it returning an error? Okay, it is. Anyway, it is not matching with our requirement. So what we can do is, we can suppose if it's going to be a return, actual return type, the successful return is going to be a vector 8, and there is a method in Rust is called map error. So what it's going to do is, it's going to accept a closure. Closure is nothing but an anonymous function. I don't have any parameters for this one now. I'm just saying decryption failed. And see, one more thing, we have to take the ownership of this string. Ownership is everything in Rust. So if you miss out this one, it will be another issue by the compiler. So what it's going to do is, now I'm not going to use the semicolon here, because I'm going to return the value from here. So if it's going to be a successful decrypt, it's going to be I hope this should work. I'm not sure. Yeah, it's correct. So if it's going to be a successful return, it's an actual U8. And if you see here, it is not showing any other return type here, but we need a string as our error return type. So what we did is, if it's in case it's going to be an error, we map the error to this string and say this encryption decryption failed. So it's nothing but it's a way of converting our error to a type that we needed for our method. I think that's it for this one. Hopefully this is going to work. Yeah, we'll try with the real one. Real shellcode encryption option, so it will be easier for us to understand. Now we have encrypt and decrypt for both AES and XOR. So what is going to be the next thing we need? The very important part of this one is going to be the parsing option, because I will show you the shellcode. So when I'm going to generate a shellcode for in a Rust format using the MSF Venom, is a part of Metasploit project. It is widely used to generate shellcodes. So it is easy to generate shellcode. If you are not doing it from scratch, you can make use of MSF Venom to generate shellcode. And when I'm trying to generate the shellcode in a Rust format, actually it is giving me this format, the 0x format. Actual shell, for our operation, the vectors and the byte arrays need only these two characters. We don't need the first two characters, 0 and 1. We don't need, and why I'm saying 0 and 1, because this array, when we're converting this and making it as an array, it's going to be a string. Suppose imagine it's going to be a string. The index is going to start from the 0. 0 and 1 should be avoided. We have to take these two values and encrypt and decrypt over there. We don't need the first two. This is a case of Rust format. Suppose if it's going to be C format, the format of the shellcode is a bit different. It's going to be /x. See, even if it's going to be /x, what we're going to do is, we will be removing these two first /x option, and then we take only this one, the second 0. This is the 0th element, and this is the first element, and we are going to consider from the D and B. So that's what we are going to do next. We have to make we can say we have to define another structure, for another unit structure for that. What we can say for that, we are going to implement another structure. Can we call it shellcode parser? Shellcode parser. Yeah, let it be shellcode parser. And here we will be having two methods. In fact, one is going to be of course the parsing. So the parsing, we need the shellcode. It's going to be, let it be like shellcode is going to be a string type, and I mean string literal. The reference to the is not, is it going to be a reference, it's not going to be an owned string. And what we are going to return from here, of course we need a vector, because we are going to play with bytes here instead of the strings. So we need to return a vector from here after the parsing. What we can do is you can make use of this one. Let it be the result of resulting vector, just be a new vector. Then the first thing what we need to do is, so imagine it's going to be, okay, I'm just going to consider this case first, and if it's going to be very lengthy video, then I leave the rest to you. Oh, sorry, not this one. See, just when I'm trying to make it a REST format, actually it has the first 4 characters, then a comma. So what the first thing we need to do is you have to remove the commas. So what we can do is just split, just say shell splits, and just dot split. Oh, sorry, it's a string, right? Then yeah, split, and it's not space, but it's going to be comma. So now what it is returning is a splitted we did split all the characters, and now we have 4. Okay, one more thing maybe, yeah, 4 can you say shell splits? No, can say shell byte, that will be more suitable. Shell byte in the shell splits. What we do is just for a safety, I'm going to trim it. Yeah, just say trimmed byte equal to, just for to ensure that nothing else is left on that, just trim it, trim the byte. Then here is the catching part, we have to clean the byte. So as I said, we need to, for performing the encryption and decryption, we need a cleaned byte. We have to avoid the /x and what to say, the 0x from our shellcode. We have to get exact characters. We remove the first 2 characters and take the other 2 characters. Sorry. So for that, after removing, I mean just removing all the unwanted stuffs, just trim the byte. Then let us say let clean byte, cleaned, okay, let's say cleaned one. So the cleaned one is going to be like what should be trimmed strip prefix. Yeah, this could be a method. Just remove the 0x, and if it's going to be an issue, I mean if there is no 0x in this one, it could be that trimmed version itself. Like let us try this way. Yeah, this is a good suggestion from the AI. We are going to remove the 0x, then So but this one we are not considering the case of /x, so just bear with me now. We are just testing it. So we just remove the 0x. Now we have the actual clean byte, and I think what we can do is we just so we know how the cleaned byte, but the next very important thing is we have to convert this the byte to a hexadecimal value. Is not the actual the string that we need to do. We have to convert this the string value to a hexadecimal value to do the actual operation. So for that, what we have to do is we have to do an operation on the cleaned byte. So let it be, so what should be the best way to do that? Converting, yeah, there's actually, this is the method we have to use. It's called from str radix. What it's going to do is actually it's going to take a string value, then it is going to convert that to hexadecimal, I mean the 16 base number system. So let us do that, and just push that to this one result, and after the loop return just return it result. Yeah, is this resolve the issue? No, it is still having some, what is the error it is showing? It might be some very function allowed. Oh yeah, that's very very good error. Did we declare the oh no, we didn't declare it. That was a mistake. And implement shellcode cipher. Now I think it is fine. That was a big mistake. What about now? Oh, what is it? Oh no, we are missing the basics here. It will be like this, and implement shellcode cipher. Now it is what is going to be this error now? Oh, sorry, name again. I'm losing in between. What about this one now? We have a shellcode parser, and the shellcode parser implementation is here. Oh, it's getting stuck. Don't get hang up now. Now we have a result type, and that is a vector. What is saying now? Expected. This is correct, right? Vector is defined. It's a new mutable vector. Then we are doing the operations, and the shell script is splitted. We got a splitted array of strings. Then we did the operation. So it is saying something, syntax error, semicolon, where it is expecting semicolon. Oh my god, did I lose somewhere? This is the mute result is fine. Does it need any other semicolon somewhere? Oops. First of all, just make the spelling mistake correct. Pass. Then let it be, okay, let it be a vector. Oh sorry, that was a mistake. This is a clean mistake. Oh my god, sometimes, yeah, after spending a long time in front of this one, I think this is now is correct or not. It should be correct. Vector, yeah, see, now it is okay. So what we are doing, I am not sure it's going to work perfectly, because the previous time when I tried in a different way. But yeah, let us see how it is going to be. The next method what we are going to do is we need another method that is going to format the data for us. So for formatting, we are going to accept this one. Yeah, try to take the try to take, oh yeah, now it is suggesting properly. We need the format type and the input, and its return type is going to be a string, of course, and if it's going to be hexx format, then we do map. Yeah, this is I think it should be formatted in this way. 0x this was the proper form, and yeah, see, this is saying, we are saying that we need to add 0x in front of the hexadecimal format we are doing. And what is this one? There is a collection. Why the collect is like this? So if it's going to be slash x, you are saying, oh yeah, again, or this slash may not be working because you have to escape the slash and say x, x, and just it will be the same 0x, but the format is having some issue. Let me, it was not showing like this the previous one when I did. No, the best way is actually, we don't need to map is okay. We are iterating over every characters, and the mapping is done on every byte. The format is going to be this format, 0x this way, 02x byte, and this byte is going to be here. We are not collecting here. Instead of that, it's very simple actually. There is no need of this one. So we are taking the value, we are mapping it, and we just format it using this one. What if we do the mapping now instead of this way? Okay, we can do it in a different way. This is a complicated suggestion from the AI. So what I think is we can no, instead of doing this one, what we can, because every byte needs to be, so I am not sure about this performance oriented, but let us see that. We are going to iterate over the input dot iterate, then dot map. The map is going to be on every byte. byte. Let's make the symbol variable byte. Then every byte is going to consider against the format match, because we have to convert every byte of the result to this format. So we have to format like that. We have to format match on here. Then did I miss? I think, okay, where is that? Yeah, this one should be the end of the map. This should be the end of the map. Why it is acting with weird? This should be the end of the map, I think. On the format, match format, what you have to do is we have to check the format type. It's going to be hexa 0x format. Yeah, this is correct now. See, now it's adjusting properly. And yeah, we have to collect the entire stuff and convert to vector string array and do a join. But yeah, now it is correct, right? See, let me see this one. Because we have to iterate over every byte and you have to format the byte with the 0x or /x according to the user. But there's an issue on the encryption and decryption now, because even the parsing we didn't consider the way of the /x, because /x format, if you check the shellcode I showed you, that's going to be another challenge now. I'm not going to waste time on that one. I am leaving that to you. The /x format is like this, like there's no specific commas and it is just coming at us like lines of strings. So consider that one also when trying to format encrypt or decrypt. And what is there now here? So here, yeah, it is missing the end of this one. Oh, it's a cargo check is taking time. Now what we did is we just iterate over every characters inside the vector array. Then we check what format it is the user is selected. For the output, if the output format is 0x, then we format it using this one. And if the format is this /x, is going to be /x string, but it is not correct for the /x. Actually, /x we had to consider a different algorithm for making it. Just for testing purpose, I'm just keeping it here. You can make changes on the /x part. So now we have the data parsing option. And why it is not moving? The cargo check is literally taking so much of time every time when I save this. Is it over? Okay. Now we have, I think, almost everything we need. So instead of yeah, just print it anyway. Now we have to literally use this all the options. So what we can do is yeah, it is suggesting shellcode to read the shellcode. So but I'm not going to call it as shellcode. Let's be the raw content. Let us call it as a raw content, the content of the file. And yeah, of course, read what is read to string? I think read to string is there. Read to string, and the path is going to be inside the config that we already filled. And the path is the path. I think the path. yeah, I think it's a path. We'll check it if it's an error. So if it's not going to be if there is any error on the reading, we just say could not read the shell code file. Now we have the raw content. Now let our shell code be parsed for us. So we all the shell code parser, yeah, we are passing the raw content and we are getting the actual shell code back to us. So now the next thing we need is our selecting the engines. So here we are going to learn something new. I already explained it in the beginning. So what we are going to do is call it as cipher engine or something. Cipher engine. Then we are so here we are going to do a box type. We are sending this to a box, and we are going to use the dynamic dyne keyword. Then the trait object, we are sending the trait object to the box, and now we are going to match the user's algorithm. So suppose if it's making too much of unwanted data, just make a semicolon here for the match, and otherwise it will be difficult to manage it again. So if it's going to be algorithm .AES, if the user is selected AES, then it's going to be the box type. I mean, we are specifying the type of the object for the shellcode cipher is going to be AES shellcode cipher, and if it's going to be XOR, it's going to be an XOR cipher. This is called dynamic dispatching. At the compile time, the compiler doesn't know what kind of object is going to come on this one, so we throw it to the box type. Box is going to be what is going to happen on box type is like it's going to create a stack with a pointer, but the data is going to be in the heap, just like the other vectors and all. So definitely if you ask for the performance stuff, heap is a bit slower than the stack, but for these kind of applications the end user will never feel the speed issue, and this is really good for us because there is another way of doing it. Definitely there will be a way of doing it using the stack itself, but now we learned a new stuff here, like the box and dynamic type. Box is going to be created in heap, and is going to be stack will have a memory pointer that is going to point the data on the heap. So now we did select our engine, cipher engine. So now what we need is the mode. I think this code might be good for us. Let us see. We just, after having the proper engine type, which cipher engine the user is selected, we are calling the encrypt and decrypt method according to the mode. So if you check here, this cipher engine object is actually the shellcode trait, but dynamically it is going to assign at runtime what kind of structure object is going to be. So if it's going to be AES, this cipher engine is going to be a type of AES shellcode encryptor, and it is going to call the method inside the AES shellcode cipher. That's the difference here. So this is happening in runtime. That's a beauty of having box type and the dynamic dispatch. Then after having the actual data, I mean the operation of encryption and decryption, what we need is the final output. the shellcode passing output. I think the AES suggested this one, format the result type from here to and passing it here, and the selector format, and we are printing the result. I think this is yeah, half of it suggested by the anyway, this is what we wanted to do, so it saved us time, but even we did take a lot of time to finish it. Even the challenging part is I'm not sure is going to be the correct way of this one, especially if we failed on passing, everything is going to be failed. Let us see how it is going to be. So let us build this one and just going to have one shellcode after removing all the bad characters. Just for testing, I'm just using this one. For this shellcode, actually, I'm creating a shell reverse TCP and just setting up my L host as this one and a random port just for checking the encryption and decryption is correct. See, this is the content of the shellcode, and what we are going to do is we already created a file encrypt.txt, and I'm going to give this to here, so it is finished without any errors. So the next thing is what we wanted was we had to run the shellcode cipher. We need these parameters. Mode is ENC, algorithm is XOR, format is hex0x. Is that the format? I forgot. What was the format? XOR. Oh no, it's just 0x. 0x, and password is encrypt, and path is this one. Shellcode encrypt this text. I think it did something. But if you want to see exactly it is correct or not, we have to copy this and create another file called decrypt.txt. So now we did encrypt it, so try to decrypt the same. So using the same decrypt and hexadecimal format, what was this? Oh, the password, yeah. The password. Okay, and this one is going to be decrypt text. So if the decrypt text is creating the same content as the first file, so our shellcode generation is correct, or we can compare it here, or I think it's correct. See, the first two characters XDA C3 BF 26 0Z 9A, oh, it's correct, it's working perfectly, and the last 050 0x1. So the parsing is really good, parsing is working perfectly. So now we did the XOR, but you know, in real time XOR may fail because, as I mentioned in the beginning, some of the EDRs and AV engines, its runtime detection nowadays is catching the XOR operations as suspicious. So it's good to try with the other one, AES. So for AES, I think we had to move this one, AES and Xerox format, encrypt this, and this did take a delay. It depends upon the number of iterations you do on the PBK df2 function. then for creating the 32-byte password, the 32-byte key for us. So now we have this one. Now we remove this. I hope if the parsing is okay, this will work fine. Now we have not ENC, we have to pass DEC, and this is this one. See, anyway, now we are printing to ensure that our options were correct. Selected AES and format this one, encrypt password as encrypt and decrypt as text. So just check this one now. Oh yeah, it worked perfectly. 0DA 0xDA C3 BF26, DA C3 BF26, 0C0Z 9A, and yeah, we did it successfully. It is working now. It's a full-fledged project that you can make use of generating shellcode encryption and decryption. But this project is not going to stop here, because you need a loader for this one. So as I explained in the beginning, if you want to run this shellcode somewhere, your application should be able to implement the same logic. Like if you are going to use AES output from here, you should be able to implement the AES decrypt inside your loader function. Loader in the sense there should be a binary or DLL that is going to make use of this encryption or decryption. So that should have the runtime capability to decrypt the shellcode and run it in memory. So that part we will do it on next video, because this is really a big one. I don't want to make it more confused now. And why I selected this way of implement, because there are so many other ways to implement this project without using these trades and dynamic dispatching. It could be done in a different way of doing very straightforward. But just to show you how good Rust is for these kind of stuffs, and to do it in a Rust specific ways, like trades, structures, enumerators, and the other stuff that we learned. I think we learned a lot of Rust today. These derive macros, why it is used, and these kind of stuffs. We came across the data structs and unit structs, implementation blocks, the trades, then trades implementation. Then we did came across these kind of, this implementation for XOR. This is a Rust specific way of doing stuff, mapping iterators and enumerators, these functions and what it does. Actually we did XOR a different manual way last time, but now we just followed the Rust way. Then again we did actually did the same thing that AES we were doing the last time. There was nothing new, but this part was new. Last time we did a different way. And the same for decryption. So yeah, the parsing was another important part here. We did learn a lot from here. The split function, and how did we trim the 0x. Now the challenge is going to be, if you are planning to take it to the next level, it should accept the /x format, and it should make that also. Considering that also, then that will be a different format, because /x doesn't need commas. It is kind of strings, so that I showed you now before the 0x. So that's it. Like now you know how to create objects of structs, and how to call methods, how to read from file, how to do the dynamic dispatching, trades implementation. I think we did learn most of the Rust specific things today, and this tool is really perfectly working. And now the next step is you have to make a loader for this one. I'm leaving that to you. We will be continuing with the encryption part a little bit more, but I will try to release this as a tool, and soon you can expect this in my GitHub, just after considering the other part of the shellcode and make it as a shellcode loader. So that's it for this video, and this was very long video, I think. Yeah, it is almost like same as the last video, but unfortunately we had to clear all these things, and if you were not catching anything from this project, just try to rewatch it. Maybe if you want to learn something in Rust, I have seen a lot of tutorials that they don't teach you the project based way, but they try to give you a lot of Rust features that always make confusing. So yeah, it's up to you if you want to make it like learn Rust based on projects, or if you want to just learn the Rust features and you are really good on these things. It doesn't matter for you. So anyway, if you are interested in Rust, you can just stay here and consider the effort. If you subscribe and like the video, that will be really encouraging for me. I can make more videos like this, but I will continue definitely. And thanks for the 20 subscribers. I just started and I got 20 subscribers, and that's really thanks for them for supporting me. And if you like this video, just do the same, subscribe and stay tuned. I'll be coming with more videos on Rust, not only on Rust, EBBF and so many other programming languages that I was discussing on the other channel. So see you soon with a new one. Till then, it's a bye from Root and Out. See you soon.